This is part 4 of the review for our CFA coming up on February the 8th and 9th. And we are completing the part of the review that has to do with quadratics. We've been working with solving using intercept form, identifying various critical information we can tell from intercept form, finding roots, graphing, axis of symmetry, y-intercepts. And so now what we're going to look at is actually solving using the factoring, because we just got done doing MF-DARM and difference of squares and GCF, greatest common factor. So what we're going to do now is we're going to look at solving by factoring. So let's look at these quadratics. Again, quadratics, second degree. X squared is your largest term. So in this example, we have 5x squared equals 10x. And there's two ways we can solve this. The first one, if we're solving by factoring, then what we have to do is we have to get everything on one side of the equation and 0 on the other side. So what I'm going to do first is I'm going to subtract this 10x from both sides, and I'm going to move it over. So that's going to give me 5x squared minus 10x equals 0. And I can't combine the x squared and the 10x because this is a squared term, second degree, to the second power, and this is to the first power. When you're adding and subtracting, you can't combine things that don't have identical exponents. When you're multiplying, you can multiply them together, but with addition and subtraction, you cannot, only with multiplication and division. So now the question is, I've gotten to this point, what do I do next? Well, let's look and see if I can find a GCF, a greatest common factor. And if I look between these two terms, if I look at my constants, my coefficients, I can pull out a 5. I can factor out a 5. They both contain a 5. Then I have the variables, which are x squared and x, and those both contain at least one x, so I'm going to factor out that x. That leaves me, again, remember, this is like reverse distribution. Instead of multiplying the factor in, we are dividing everything out. So I'm going to take 5x squared and divide it by 5x. 5 divided by 5 is 1. I don't have to write that. It's understood. And x squared divided by x is x. Then if I take 10 divided by 5, that is 2. And x divided by x is just 1. So I leave it just like this. So now I have 5x times x minus 2 equals 0. And if you remember from the first part of the review, we actually need to find out what values make these two factors equal 0, because this is a product. We are multiplying this factor times this factor and getting a product of 0. So it doesn't matter which one comes out to be 0. As long as one of these equals 0, one of these two factors, this will be true, and I will get 0. So first thing I'm going to do is I'm going to take my first one, 5x, and I'm going to set it equal to 0. I want to know what makes 5 times x equal 0. Well, to solve it, I divide both sides by 5. You divide by what's in front of the variable. That leaves me with x equals 0. So 0 is going to be one of my solutions, which is one of my intercepts. Then let's do the other factor. X minus 2 equals 0. So in order for that to equal 0, x has to equal 2. And remember the pattern we talked about earlier. You can tell it's always the opposite of what's inside. X minus 2 means the solution will be positive 2. Whereas x plus 3, the solution will be negative 3, because that's what makes this expression 0. So my two roots, or my two solutions, are going to be x equals 0 and x equals 2. So that's how I solve a quadratic expression such as this one. So on the next expression, we have what we worked on previously. We've got a trinomial. And to solve this by factoring, what that means is I'm determining the x-intercepts. And if you remember, what is the y value at the x-intercept? 0. So f of x, which is essentially our y value, we're going to put a 0 in for f of x. So I'll go ahead and follow the color coding here. So I have 2x squared plus 11x plus 5. Now, I'm going to need to factor this out so I can solve it the same method as I do here. This is in standard form, and solving it for the intercepts means I have to put it in intercept form. Okay? First of all, do I have a GCF between 2, 11, and 5? No, I do not. So that means I'm going to move on and use MF DARM. So I'm going to multiply my A and C term. 2 times 5 equals 10. So I'm going to factor the 10. I've got 10 and 1 and 5 and 2. And looking at the sign of the C term, which is a positive, I'm looking for two terms that add to give me a value of 11. And that is 10 and 1. So I'm going to write my factors here, my binomials. I'm going to have x and 10 and x and 1. So I've taken care of the multiply A times C. I've taken care of the factoring. Now my next step is I'm going to divide by the A term. So dA is divide by A. So my A term is 2. So I'm going to divide these by 2. And one of the things I forgot to put in there were the signs. And because it's positive, that means the larger one's positive. And because the C value is positive, they both have to be the same sign. Because this times this has to give us the C value, which is positive. So it's either negative, negative, or positive, positive. So now I'm going to reduce. 10 divided by 2 is 5. So I can reduce that one. But I cannot reduce 1 over 2. So after the reducing, since I've done reducing, I'm now going to go to the moving. I'm going to take the 2, move it in front. That gives me 2x plus 1. And remember, this is all equal to 0. My y value is 0. I'm looking for where y is 0. So what do I do here? Same thing I did up here. I'm going to take each of these factors and set it equal to 0. So x plus 5 is my first one. So if I subtract 5, x can equal negative 5. Negative 5 is what would make this factor 0. So let's try the other factor. 2x plus 1 equals 0. I'm going to subtract the 1, and that gives me 2x equals negative 1. And then I'm going to divide both sides by 2. So x equals negative 1/2. So our two roots are going to be, or our solutions, which are also called solutions, negative 5 and x equals negative 1/2. Those are your two solutions to number 26. So let's do number 27. We're going to use MF DARM again. I've got MF DARM up here. There's nothing common between 2, 5, and 2, so I can't factor anything out. There's no GCF. So what I'm going to do now is I'm going to go through the MF DARM process. So I'm going to multiply A times C, which is 2 times 2, that's 4. The factors of 4 are 4 and 1 and 2 and 2. You look at your C term, which is plus, so I'm going to be adding these. So I've got 5 and 4. And I'm looking for something that gives me my B value, which is 5. So that would be 4 and 1. So I'm going to go ahead and write my binomials here. I have x and 4 and x and 1. Because my B value is positive, that means my largest factor has to be positive. And because my C value is positive, that means they have to be the same sign. So now, let's divide. We're going to divide by my A term, which is 2. So we divide both of these by 2. And then I'm going to go to the R, which is reduce. And I can reduce 4 divided by 2. But I cannot reduce 1/2. So what I'm going to do with 1/2 is I'm going to take that 2 and I'm going to do the M part, which is move it. So that becomes 2x plus 1. And remember, these are all set equal to 0. Our y value is 0. At every x-intercept or every 0 or every solution or every root, the y value is 0. So now I'm going to take my roots and solve over here, my two factors. So x plus 2. Let's set x plus 2 equal to 0. You've probably figured out the pattern by now. So x is going to be negative 2. And then I'm going to set 2x plus 1 equal to 0. I'm going to subtract 1 2x equals negative 1. Divide by 2. I'm just solving it like any algebra equation. And x is negative 1/2. So my two roots for this example here would be x equals negative 2, and I'll just circle them for you, and x equals negative 1/2. So those are going to be my two roots for that one. Okay, so let's look at our last example, number 28. Let me slide the paper up a little bit. Number 28, 7, 53, and 28. The question is, do I have any numbers that go into all three of these? And the answer is no. There is no GCF for 7, 53, and 28. So I'm going to go straight into MF-DARM. So we'll multiply 7 times 28. And when I multiply 7 times 28, I get 140 and 56, so I get 196. And again, this is going to be a pretty big solution here. So I've got 196. I'm going to factor 196. I'm looking for two values of 196 that are going to give me 53. So you can use your calculator for 196. 196 is actually 14 times 14. That's kind of our middle of the road because it is a perfect square. So it is 14 times 14. And then, well, we have the twos. We can do 2. And 196 divided by 2 is 94. But that's not going to give us what we're looking for. So let's try 4. So if I put 4 into 196, I get 49. And as I'm looking at this, I'm looking for factors that add. You can do every single factor if you want to. I'm just trying to shorten this up a little bit. I'm going to be adding, and I do have 4 plus 49 does give me the 53 I'm looking for. So that's what I'm going to use here. So I'm going to come over here, and I'm going to have x and 49, and x and 4. Because my b value is positive, that means my largest factor has to be positive. And because my c value is positive, that means they both have to take on the same sign. So now we've done the multiplying for the MF-DARM. We've done the multiplying and the factoring. Now let's do the dA part of DARM. Divide by a. My a term is 7. So I'm going to divide both of these by 7. Then the r is reduce. So 49 divided by 7 actually reduces to 7. However, I cannot reduce 4 over 7, so I go to the last portion of MF-DARM, which is M, which is move. So I'm going to move the 7 in front, so I have 7x plus 4. And once again, remember, all of these are set equal to 0 because we are looking for the x values when the y value is 0. So in order to solve these, I'm going to take my two factors and figure out what would make either factor a 0. And you're getting good enough at this that you can tell. So we'll take a little bit of a shortcut here. What is the opposite of positive 7? Negative 7. So you know that negative 7 is one of your answers. However, 7x plus 4 is not that straightforward. So I'm going to take 7x plus 4 and set it equal to 0. Subtract the 4, 7x equals negative 4. Divide both sides by 7, so x equals negative 4 over 7. So your two roots, or solutions, or zeros, are going to be negative 7 and negative 4/7. Now it's important to note, when you solve by factoring, all of these that we've done solving by factoring, these values that you're coming up with, those are your solutions, but they're also your x-intercepts. So if I were to graph these quadratics on the graph, these x values I'm coming up with would be the two places on the graph where my parabola actually intersected the x-axis. So if you look back at number 25, we got 0 and 2. What that means is if I were to graph this parabola, that means that this parabola is going to intersect the x-axis at 0 and 2. And since my a value is positive, I know it's going to open up. So it's going to look something like this. Okay. So now let's go down and look at number 26. If I'm looking at number 26, my two values are -5 and -1/2. If I were to graph number 26, I would have a point at -5, and I would have a point at -1/2. And because this is a positive a value, it opens up, it's going to look something like this. If I were to graph number 27, and I'll just graph it on the same graph with a different color, number 27, my values were -2 and -1/2. So for number 27, I would have a root at -2 and a root at -1/2, and it would look something like this. And for number 28, which is the one that we just graphed, I would have a root at -7, so it would be out here. And I'd have a root at -4/7. And -4/7 is a little more than a half. So it'd be right there, around there. So those would be my two roots. Again, my a value is positive, which means the parabola would open up. But you can see that's the significance of those x values that you just found. So we were solving for the solutions, which are also the x-intercepts, the roots, or the zeros.